What if I told you that the game controller in your hands is more advanced and more different than you ever imagined? Today we're diving inside the controllers for Xbox and PlayStation, reverse engineering what makes each tick.
Why do they feel different?
What secrets are hidden beneath the buttons and sticks? Stay tuned, because you're about to find out, and it may change how you view every gamepad you pick up. Cue dramatic visuals of controllers being opened up, circuit boards, wires, components. If you love tech you can hold in your hand, smash that like button, subscribe, and let's get into it. First, what does reverse engineering a controller actually mean? It means taking it apart, reading the clues of how the sensors were built, the triggers, the vibration motors, and understanding the design decisions behind them. For gamers, engineers, and models, this is pure gold. Consider this. Controllers started as simple D-pads and buttons decades ago. Today, they embed gyros, haptics, and adaptive triggers. Research shows that manufacturers are pushing component density and automated assembly to a whole new level. For example, a CT scan study of PS5 and other controllers highlighted this evolution in engineering. So by reverse engineering, we can ask, what's under the shell? What design choices were made? Ergonomics, layout, sensors? Which platform gives you more value or better performance under the hood? Let's set the scene for our two contenders. On one side, we have the Xbox controller, e.g., the latest wireless controller for Xbox Series. On the other side, the PlayStation's DualSense for PS5 or its predecessor DualShock. Let's compare their external form first. Xbox. Offset analog sticks, left stick higher than right, larger triggers, robust grips. Some gamers say this layout improves ergonomics. Indeed, a Reddit discussion noted, the Xbox-style controller layout is ergonomically superior. The left stick higher up gives less thumb stretch. As PlayStation, symmetrical dual sticks at the bottom, face buttons, iconic layout with additional innovations like adaptive triggers and haptics in DualSense. The Wikipedia entry for the DualShock's DualSense line captures these features. Internally, a tear-down approach shows sensors for sticks, triggers, vibration motors, Bluetooth wireless modules, power supplies. One tear-down PDF shows the analog stick module, vibration motors, radio module, and battery. So what happens when we crack them open? Let's find out. Step 1. Shell removal. You remove hidden screws, pry open carefully, and note how manufacturers hide key fasteners to promote a clean exterior. Step 2. Analog sticks and amp sensors. These are typically potentiometer-based sticks, analog stick definition, that register fine thumb movement. When you move the stick, it changes resistance. The controller reads XY values. The engineering here is critical because precision matters drift, or inaccuracy ruin gameplay. The teardown document noted stick drift and how dust obstructions can affect performance. Step 3. Haptics and amp vibration motors. For example, the DualSense includes linear resonant actuators and adaptive triggers that can vary resistance and feedback. This is a leap forward in immersion. On the Xbox side, the design might be less flashy but highly optimized for broad compatibility, PC, console, and ergonomic comfort. Step 4. Wireless module and power. Both controllers require a lithium-ion battery, Bluetooth or proprietary wireless radio, PCB for signal processing. The density of components has grown, assembly is automated, tolerances tight. One study pointed to this trend of increasing component density and faster assembly times. Step 5. Ergonomics and amp layout internal decisions. For example, the offset stick on Xbox is intentional to match natural thumb placement. PlayStation's symmetrical sticks keep a balanced feel. Research shows these design decisions matter for usability. So what's the takeaway? Under the shell, both controllers are marvels of engineering. But the choices they make differ, and those differences matter. Now let's compare key differences and break down what they mean for gamers, modders, and engineers alike. 1. Analog stick layout and amp. Ergonomics. Xbox. Left analog stick is higher up than the right stick. Offset. Some argue this is more comfortable for longer sessions. A PlayStation symmetrical layout may feel more intuitive, especially for those used to PS style. What this means to you, comfort matters. For long play sessions, hand fatigue will add up. If you mod or open the controller later, layout affects internal and cable routes. Do trigger and amp, bumper design. Xbox, traditionally large triggers, RTLT, and bumpers, designed for robust durability and heavy finger games, shooters, racing. A PlayStation DualSense adds adaptive triggers, resistance, and more advanced haptics. What this means: if you play games that take advantage of these features, racing, immersive shooters, PlayStation may have an edge. If you want proven, broad compatibility triggers, Xbox shines. 3. Internal component density and amp. Build quality. The CT scan research shows newer controllers pack more components, smaller tolerances, automated assembly. Xbox controllers often emphasize durability, since they're used on PC, console, third-party mods. PlayStation pushes innovation in feedback. Say what this means. If you're opening your controller, repairing, modding, the quality and layout matter. 4. Ecosystem and amp compatibility. Xbox controllers frequently plug and play on PC with wide driver support. PlayStation controllers offer richer features in native games, haptics, triggers, but may need extra support on PC modding. What this means: choose based not just on feel but what system game you use. 5. Mod-friendly, reverse engineer-friendly. When you open the shell, Xbox may have cleaner layout, widely documented. PlayStation may include more complex features, adaptive triggers, which are exciting to explore. For both, be mindful of warranty, screw types, internal flex cables. So there's no absolute winner. The better controller depends on what you value: ergonomics, exotic features, mod friendliness, cross-platform support. If you want to try reverse engineering your own controller for learning, repair, modding, here are some professional tips. Safety first. Unplug, remove battery if possible, discharge static, work on a clean surface. Document everything. Take photos before and during disassembly. Label screws and parts. Use the right tools. Trocks or security screws are common. Plastic sludgers prevent damage. Identify key modules: analog stick modules, triggers, vibration motors, PCB. The Robot Events PDF shows how to inspect analog stick modules for dust or obstructions. Understand PCB traces and amp wiring. Look for how buttons connect, wireless module seats, battery connector placement. And consider ergonomics when reassembling modding. If you change stick height or button travel, you'll affect feel. The research on control ergonomics shows these matters. Warranty and legality. Opening the shell may void warranty. Also, these controllers are copyrighted hardware. Reverse engineering for learning is fine, but commercial copying may violate laws. If you follow those steps, you can start to learn why the controller is built the way it is, and perhaps build your own custom version or mod for improved performance. Looking ahead, controllers are not going static. New features like haptic feedback, adaptive triggers, gyroscope sensors, see recent research, are pushing what's possible. For instance, might future controllers include force feedback surfaces, biometric sensors, modular designs? When you reverse engineer today's models, you're peeking into the foundation of tomorrow's gadgets. So, if you're a gamer, engineer, or tech enthusiast, keeping up with controller design gives you an edge. Not just in knowing how your gamepad works, but understanding how you interact with games at a deeper level. So to recap, we took controllers apart, virtually, and saw what's inside. We compared Xbox versus PlayStation in layout, ergonomics, internals, modding friendliness. And we gave you actionable tips for exploring hardware yourself. If you find value in this deep dive, hit that like button, subscribe, and ring the bell so you don't miss our next teardown. If you loved the video, share it with your game friends who might still think all controllers are the same. Comment below. Which controller do you prefer, Xbox or PlayStation, and have you ever opened it up? I'll dig through your comments and feature some of the best ones in the next video. Thanks for watching. Until next time, keep gaming, keep exploring, and keep learning.